Alright, I would like to look at graphs of functions. What we're going to do is we're going to graph a couple of functions, and how we're going to do that is by finding the ordered pairs x comma y, or utilizing function notation x comma f of x. The first function that I would like to look at is x squared plus 4. This is not a linear function, but we can still graph it by finding the ordered pairs. Here we have it written in function notation, f of x equals x squared plus 4. And I've arbitrarily selected these points centered around the origin. So from a negative 3 to 3. Again, this is my input. This will be my output. This is the correspondence, the relationship, the ordered pair that they create. This is my domain. This is my range. Okay, so what I do is I simply go through and I work and solve. So I say, okay, whenever f is a negative 3, and I plug in a negative 3 for that, what is y? So whenever f is a negative 3, y equals a negative 3 squared. How to view this? A negative 3 times a negative 3. That's what it means to square something. So a negative 3 times a negative 3 is 9. Negative times a negative is a positive. So f of a negative 3 equals 13. And then f of a negative 2, we do it the same way. We plug it in. I substitute a negative 2 for x. So that is a negative 2 squared plus 4. Negative 2 squared will give me 4. So 4 plus 4, and that's 8. So 8. Alright, now I want you to pause the video and you complete working these to see if we end up with the same answers. Okay, so let's see. So f of a negative 1 equals a negative 1 squared plus 4. So a negative 1 is simply 1. 1 plus 4 is 5. And f of 0, we'll write it up here, f of 0. F of 0, simply 0 squared. 0 times 0 is 0. So f of 0 equals 4. F of, and we'll replace that with a 1. F of 1 is 1 squared plus 4. So f of 1 equals 5. Let's move down here and we'll say f of 2. F of 2 equals 2 squared plus 4. 2 squared is 4. So f of 2 equals 4 plus 4, which is 8. And in my last one, f of 3. F of 3 equals 3 squared plus 4. 3 squared is 9. 9 plus 4 is 13. Equals 13. So we'll go through here. So when f of 0, that is 4. And f of 1, that is 5. And 2 is 8. 3 is 13. So what I have here, these are my coordinates. A negative 3, 13. A negative 2, 8. A negative 1, 5. 0, 4. These are my relationships, the correspondence. My x values deal with my domain, and my y values are my range. So there are my coordinates right there. So what I'm going to do is I'm going to graph these coordinates on my graph, and I did label it numerically this time to be able to help us since we're going to be graphing so many points. So the first one, negative 3, 13. So negative 3, 13. And then a negative 2, 8. And then a negative 1, 5. And it's 0 and 4. And then 1 and 5. And 2 and 8 and 3 and 13. Now, again, this is why I say it's rudimentary. It's just an understanding of how does my function look, because all the other points in between here, negative 1.1 and so forth and so on, I didn't actually evaluate. So I'm just guessing as I sketch my graph. So there's my graph sketched. One thing that I want to point out for for your problems, and this goes with all of your functions, if there is a constant that's a number without a variable next to it, that is always going to end up being your y-intercept. Remember, your y-intercept is where your value of x equals 0. So whenever x is 0 for this function, f of 0, y is 4, which is always that constant. Okay, so what we did was we found ordered pairs and we made a rough sketch of our graph. And here, I'll actually try to make that show up better on the screen. This is a quadratic function. X squared will give you a quadratic function. So what we graphed here is a quadratic. What we had been working with is linear, but we can still graph them the same way. A quadratic function. Okay, now what I would like to do is show you one other thing on here. Again, let's reiterate though before we do, is that my x is my domain. That is my input. All of these are input. My y is my range. All of this is output. All of that's the output. Remember, I plug this in, I get this out, and I end up with a correspondence. Let's see if I can write this. Correspondence. This is my relationship. Okay? This is my relationship. Again, we have to make sure that this is remembered and looked at. Each value in the domain corresponds to exactly one number or value of the range. And I had no extra x values in what I did. Okay? No extra domain. I did not have a negative 3 equaling 13 and a negative 3 equaling 12. And then we're going to take a look at how we can look at that graphically, what we just spoke of. But this right here, all right, the last thing that I want to talk about is the vertical line test. We spoke of the correspondence and the relationship last lesson and just with this one, showing how the domain, the x values, that each value in that domain corresponds to exactly one and only one value of the range. Well, this is a way to be able to view that except graphically. It's called the vertical line test. If a vertical line crosses a graph more than once, then the graph is not a function. So using a vertical line, you can simply use a straight edge, a piece of paper, your pencil. But as you slide this along, if it only strikes the graph one time, then it is a function. So this is a function. And here, this one, if we slide a straight edge along, I'm only intersecting that graph at one point along that graph as I go along. This is a function. But then we get to where we have an intersection, and I went ahead and drew the vertical line on there. I'm intersecting this graph in two different spots each time as I'm going along. Again, each value in the domain, the x value, corresponds to exactly one value of the range. If right here, if this is, let's say x equals 1, then what that means is that whenever x equals 1, I get two values. We'll say I get a 2 and a negative 2, meaning that I have 1 going to 2 and negative 2, or else what I have is 1 comma 2, 1 comma negative 2. Not a function. Not a function. Look at another one. Again, this one's not a function. Actually, our y-axis shows us that because it strikes the y-axis in three different places. Not a function. Given the graph of a circle is not a function. Strikes the graph in two places with the vertical line. So again, remember, each value in the domain corresponds to exactly one value of the range. Here I had two values in the range, two values in the range. This one I had three values in the range. For whenever x equals 0, I could get three different values. Not a function. Guys, good luck with your homework.